So just some reminders before we get into the video. First reminder is to make sure that you're keeping an eye out and an ear out for the key word for this lesson. Reminder number 2 is to make sure you're taking notes. Include the date, lesson number, aim, and standards to help you refer back in your notes. Let's get to it. Okay, and welcome back. So today we're going to be going over lesson 3 in unit 1. Our aim for today is going to be how do we use absolute value in a real world situation. So the first thing that we want to go over is the definition for absolute value. It is the distance a value is from 0 on a number line. Now, depending on your teacher in the past, you might have gone over absolute value, which is okay. Again, majority of Unit 1 is a big review of a 6th grade, a 5th grade. So just a couple of rules for absolute value to go over and just to review. So the first thing you want to remember is your answer for absolute value is always going to be positive. Okay, your symbol for absolute value are going to be 2 straight lines. So you have 2 lines that surround the value. The way you would say the expression, let's say we have, so this would be the absolute value of -4. Okay, so if you have the absolute value, or you're looking for the absolute value of -4, your answer again is going to be positive. There are some exceptions. We're going to go over those later on in the video. Okay, so let's move on. We always associate absolute value with a number line. So using the example I had before, the absolute value of -4, if I plot -4 on the number line here, -4. Again, going back to the definition of absolute value, it's a distance that value is away from 0. So you'd say 1, 2, 3, 4. -4 is 4 units or 4 away from 0. But what if we look on the other side? Let's say we have the absolute value of 4. So our answer here is 4. We're looking at 4 now, +4. We're looking to see how far away from 0 4 actually is. And we know it's 1, 2, 3, 4. So again, it's 4 units away from 0 on a number line. As I was saying earlier, with the exception, let's say you have the absolute value of -4, but you have a negative outside the absolute value symbols. Your answer inside your absolute value is going to be +4. But this negative on the outside makes your answer turn negative. So this would be your exception to the rule. So if there's a negative outside of the absolute value symbol, you're going to have a negative answer versus your absolute value, which will always be positive. Okay, so let's go over some problems and examples. So the first one, a diver started at 45 feet below the sea level. Over an hour's swim, the diver swam 22 feet deeper. What is the distance from the surface of the water? Use a vertical number line. So just like we had a horizontal number line, you can use a vertical number line to help you visualize the depth of the water. So if you have the sea level, that's 0. The diver started at 45 feet below, so that's negative 45. You're saying, or the question is saying 22 feet deeper. So they swim 22 feet further than where they already are. So you know you're going to be farther away from 0. So you have the absolute value of negative 45 and you're subtracting 22. You can put this in the calculator. Negative 45 minus 22. You want to deal with what's inside the absolute value symbol first. You're going to get a negative 67. And now we have to deal with our symbols. So we find what the answer is between negative 45 minus 22, which is negative 67. And then we get our solution, or our next step, which would be finding the absolute value of negative 67, which will be 67 feet below the water. Or below the surface, you can say. Okay. So now number 2 is very similar. You're just given a computational problem. You have to deal with whatever's inside first and then deal with your absolute value. Sometimes to help me remember, I still write my absolute value symbols down, and then I figure out what that value is going to be within the absolute value number. So negative 5.678, and you're adding 3.134 on the calculator, you are going to get negative 2.544. Then you're going to solve the absolute value of that negative 2.544, and you're going to get a positive 2.544. Or let's say if you changed it into a fraction, you would have 2 and 68 over 125ths. Let's move on to number 3. So number 3, they're asking you for the highest temperature in the summer was 102 degrees Fahrenheit in 2007. The lowest temperature that year was negative 26 degrees Fahrenheit. What is the distance between these temperatures on a thermometer? So you want to find the distance between. You can draw out the thermometer if you want. You can just write a computational absolute value if you want. Your choice. So pause the video and try it yourself, and then we're going to go over it. So we have 102. We want to find the difference between that number and don't forget the negative 26 degrees Fahrenheit. So we have the difference is going to be 102 plus 26. We're going to get 128 degrees. And you can put that in the absolute value. It's going to stay the same, but it's 128 degrees. For number 4, pause the video, try it on your own, and then come back and we'll go over the answer. So the current temperature is negative 35 degrees Fahrenheit. At night, the temperature dropped 32.25 degrees Fahrenheit. How far below 0 is the current temperature? So if we're starting at negative 35 degrees, we're subtracting, or we're dropping it another 32.25 degrees. We want to figure out how far below it is. So the wording is very tricky here. So you have to be sure you're using your absolute value. So when you plug into the calculator negative 35 minus 32.25, you're going to get negative 67.25 or negative 67.25. So the absolute value would be 67.25, 67.25 degrees below 0. Okay. Well, again, if you have any questions, make sure you ask them, and I will see you in the next video. Bye.